Welcome back, students. Okay, so we're on to question 9b, and here we have a cyclic quadrilateral. Okay, let's look at what a cyclical quadrilateral is on our appendix B. So the very last theorem, theorem 19, the angles at the center of a circle standing on a given arc is twice the angle at any given point. And leading on from that, we get corollary 5, which is in a cyclic quadrilateral opposite angles sum to 180. So here I have our close that there now, our app, or an interactive to explore this, and we can see that this is a cyclical quadrilateral. Cyclical just means forms a circle. So the 4 points here are locked onto the circle. They're variable, but they're not free. They're variable in that as long as they stay on the circle. Okay, so what we can see here is I'll just reset that to its opening positions. Not that it's necessary, but we see 180 add to 180. Okay, and then we have 90 opposite 90. Now, as I change a point, it's not the angle there that changes, because the chord CB is remaining fixed. So that it's not this that's changing; it's the distribution of the upper and lower of the two adjacent angles that's changing. You can see the more obtuse and the closer I go to a straight angle up here with the 154, it comes at a cost to its opposite angle, which is getting repeatedly smaller, or consistently smaller. Okay, so that's what the theory we're going with. And so we have that 5x and 100 should be 180. So we'll write that down. 100 plus 5x equals 180. Cyclic quadrilateral property. Okay, so transcribe to 100, we get 5x equals 80. Divide by 5, we get x equals 16, and we call that degrees. Okay. So the next thing we want to look at here is that, so we know that x is 16, and now we know that 8x, these two opposites also have to add to 180, so 8x take 13 plus y equals 180. But this is not, this is no longer, this can have x of 16 substituted. So 8, 16, that's a number we're very familiar with, because it's double 64, which is 128. 8 16s. Take 13 plus y equals 180. Now when you're dealing with linear equations like this, it's best to simplify both sides first. So what's 128 take 13? 115 plus y equals 180. Now we'll transcribe the 115 because both sides are simplified. And we have 180 take away 115, which is 65. Okay. And just to be sure, what I'll do is I'll go back to the original question now and fill that in at 65, and fill in this at 80, and I will go with my 128 take 13, which was 115. Yeah. Just double checking I haven't made any mistakes. And that should be that. No, there's another part to it. Okay, this is an interesting question. We're looking to sum up the external angles. So what I'm going to do here, so this is a very interesting, and I would call this definitely problem solving if you haven't seen it before. And so it's a bit, I'm going to step back and give you time to think about this. Why don't you pause the video and think about this? Okay, so what are the things we do when we don't know what to do? We do something. Okay, so what I'd be looking at is straight edges. Okay, and I'd be thinking of introducing variables like a, b, c, and d. Okay, that's just a creative thing I can do. Okay, Now I have 4 straight edges, and 4 straight edges is 4 by 180 is 720 degrees. Okay, but I know that A plus B plus C plus D is 360. 90 and 90 and 90 and 90, for example. Now I'm just beginning to wonder, have I made any mistakes here? Is 4, 180, 180, no? Okay, so my 4 straight angles added to 720, my 4 internals adds to 360, so my 4 externals must also add to 360. Does that seem to make sense? And I'm just going to check a bit further. So 4 externals, or if you like, W plus X plus Y plus Z has to be equal to 720 minus 360, which is equal to 360 degrees. Okay, well, we do have the back of the book, of course, we can check. So while that's a bit of a weak enough strategy, I'm going to use it right now. On B question 9, and there it is there, 360 degrees. There you go. Okay, as always, students, I will see you in the next one.